ICO2CHEM stands for Industrial Carbon Dioxide to Chemicals. The ICO2CHEM project funded by the European Union is a very important project for us because we could show that one could use carbon dioxide, which is normally emitted in the atmosphere, to produce chemicals. We have hot, dry summers in Germany. The icebergs are melting on the northern and southern poles. So of course we have to reduce the emission of carbon dioxide into the atmosphere as mankind. With respect to the challenges we have on Earth, sustainability is, from my understanding, the most important factor. We have a lot of sources for carbon dioxide production. In the household, you want to have heat inside, you're incinerating gas or coal or whatever, and of course emitting carbon dioxide. And I think this is a huge problem we have on Earth. Same is true for the industry. So chemical industry is a large user of electrical and heat energy. On the basis of fossil resources, they're producing carbon dioxide. And this is a source for the carbon dioxide. And the next step is the synthesis of materials out of carbon dioxide. We need a lot of energy, therefore, and this is coming from the hydrogen which is used. The surplus here on our side is that hydrogen is available as a byproduct from a chemical production plant in a huge amount. And this could be used on site here, so we do not have especially produced hydrogen. Carbon dioxide is still existing here on site, and we can produce hydrocarbons out of that. And the hydrocarbons could be used as fuels to fuel your car or a truck or whatever. But we want to use it in the project as a raw material to produce chemicals out of it. And this is exactly what is taking place in the MOBSU unit. ICO2CHEM is a funded project by the European Union under the Horizon 2020 program, participating institutions from research and industry from 3 European countries, from Finland, Italy and Germany. The VTT Research Institute from Finland is the coordinator of the project.
VTT focuses on sustainable fuel production. It allows the modular combination of different process units. The containerized synthesis solutions enable easy transportation to different customer locations.
Infraserv is part in the ICO2CHEM project with several jobs inside. The first of all, the important one is to prepare the site to have the MOBSU here and to integrate the MOBSU in an industrial environment like here in our industrial park. Industrial partners are INERATEC, which is a startup company from Karlsruhe in Germany, developing the reactors.
I'm the head of the operations department at the INERATEC company in Karlsruhe. Our goal and our vision is to provide sustainable, renewable, CO2 neutral fuels and chemicals affordable for everyone. Our core competences are the innovative chemical reactor technology that we use. So we use microstructured reactors to be able to scale chemical reactions and energy conversion processes in different scales and levels.
We have another partner from Italy, which is the Politecnico di Torino, and we have a third research partner, Provadis Hochschule from Germany. The part of Provadis is to support the operation of the MOBSU plant because the colleagues are understanding better the economic part of the project. Today, fossil resources are very cheap. Hydrogen is expensive. So therefore you have to see if these economic models, which have to be developed, could stay on the market. We have in the project the chemical company ALTANA, which is producing a lot of different products for their consumers. They are using, in some parts, fossil-based waxes and white oils. To do the analytics and the testing is part of ALTANA. They can decide if the material which we are producing here in the MOBSU plant is a good substitute for the fossil-based raw materials or not.
This is the mobile synthesis unit. Here we have the Fischer-Tropsch module. In the second process room we have the RWGS unit.
Our reactors can produce renewable synthetic fuels in 2 steps. In the first step, we activate the CO2 in the reverse water-gas shift reactor to provide a synthetic syngas that we use in the second reactor step, the Fischer-Tropsch synthesis, in which we produce hydrocarbons. So it's a range of different fuels and chemicals that we provide by renewable means.
This is the product sampling station. Here we obtain the FT crude, which will then later be further processed into higher value-added chemicals.
In this case, long-chain hydrocarbons, which are used as so-called white oils or waxes as raw materials in the chemical industry. And this is a step into the circular economy.